Alright, ladies and gentlemen, I'm going to look at some of the highlights from the test review on your behalf. Here is one of the problems. On the first page, number 1, the x squared minus 4. What I really want you to notice here is the structure of the table. Negative 2 squared is positive 4. Minus 4 is 0. Negative 1 squared is positive 1. Minus 4 is negative 3. 0 squared minus 4, negative 4, and then notice that we get this parallel structure. Whatever we put in a negative value or a positive value, we're going to get the same answer because of the squaring. So 3 squared is 9, minus 4 is 5, and if I were to do negative 3, I'd also get 5. So that parallel structure is a great way to tell whether or not you're dealing with a quadratic in a table. And also, from the next page, I'm going to take number 5 and solve that one for you. It's a nice problem. 5x squared minus 4 equals 406. So add 4 to both sides. For 5x squared equals 410. Divide both sides by 5. X squared is equal to 82. And then take the square root of both sides, and x is equal to plus or minus square root of 82. That's it. Final answer. You could write it as a solution set if you'd like, but it's certainly not required. I just needed you to be familiar with this notation and to not confuse it with an ordered pair. And that problem can contrast nicely with number 4. 16x squared minus 8 is equal to 1. Add 8 to both sides and you end up with 16x squared equal to 9. Divide both sides by 16 and you get x squared equals 9 divided by 16. Take the square root of both sides. Both 9 and 16 are perfect squares, so we should simplify. The square root of 9 is 3. The square root of 16 is 4. So our roots are plus and minus 3/4. All 3 of these are correct ways to represent your answer. For number 2, just think about the parent functions. This is for linear, and it makes a line. Here's for a quadratic, it makes a parabola. For both of the problems in number 6, I really did want you to have graphing technology available to you, and I know a lot of you don't have that at home. You can always build a table to figure out exactly what y equals x squared plus 2x minus 1 looks like. But the thing I wanted you to notice here is if we sketch the parabola, and while this is not exact, I've shown you how to find the axis of symmetry and the vertex. Opposite of b over 2a. So the axis is at negative 1. And then the y coordinate of the vertex is at negative 1 squared plus 2 times negative 1 minus 1. So that's 1 minus 2 minus 1. So that's negative 2. So then the vertex is at negative 1, negative 2. Right here. But an interesting fact that I want you to see is that the y-intercept right here is always going to be the same as this term on the end right here. And you can check that really easily. The y-intercept is what happens when x is equal to 0. So that's 0 squared plus 2 times 0 minus 1. Well, those cancel, leaving just the negative 1. It's a helpful feature of the quadratic that we really didn't get to focus on much in class. But here it is for those of you who are working on the review. Solve by completing the square. Here's number 8. Half of 4 squared, that's 2. Squared is 4. So we want x squared plus 4x plus 4 equals 100. because we must add 4 to both sides in order to complete the square. Then this is x plus 2 squared equal to 100, square root both sides. X plus 2 equals 10, because the square root of 100 works out nicely. It is a perfect square. Subtract 2, so x equals 10 minus 2, which is 8, and x is also equal to negative 10 minus 2, which is negative 12. And why not do number 7? X squared plus 12x equals 0. Half of 12 is 6. Square it. X squared plus 12x plus 36, and be sure you add that 36 to both sides. X plus 6 squared. Half of b is this term right here, equals 36. Square root both sides, and you should know the rest at this point. Half of b right here every time. And I'm only going to show you half of number 9 because I've done something kind of sneaky here that a couple of you might see, but I suspect a lot of you won't. Half of 24 is 12. 12 squared is 144. So you might be tempted to subtract 6 from both sides, which will work. But you might also notice that x squared plus 24x plus 144 plus 6 is equal to 15. So you can rewrite 150 as 144 plus 6, and then go ahead and complete the square. Half of 24 is 12 squared. I know I'm going to subtract that 6 from both sides to get 9, and you should be able to finish from there. Be sure you use your notes for number 10. I have no interest in going over that again in this video. Numbers 11, 12, and 13. On the test, the problems that look like this, where you're asked to use a quadratic formula, one of them is multiple choice, and your answer is given to you in these solution sets. And another one is a griddable, where you are rounding to the nearest thousandth place. So let's do number 12, and I'll write my answers both ways so you know what to look for. So here we've got A, B, including the negative sign, and C. Plug them into the quadratic formula. The opposite of negative 8 is positive 8, plus or minus the square root of b squared, so negative 8 squared is 64, minus 4 times a times c. A and c are both positive, but I'll go ahead and write it in for you anyway. 4 times a times c. And all of this is divided by 2 times a. So there it is, everything plugged in. Now simplify what's beneath the radical first. I'm going to drop the color coding because that takes too much time. We've got 8 plus or minus the square root of 64 minus 40 divided by 10. Continue simplifying underneath the radical first. 64 minus 40 is 24. All of this is divided by 10. And at this point, if you don't need to round, this is a perfectly acceptable answer. And this is what it looks like in terms of your solution sets. One with a positive root 24, one with a negative root 24. Of course, you could also take either one of those two roots and turn it into a decimal, and then round it to the nearest 3 decimal places. 3 decimal places is kind of an arbitrary choice. It's my choice. I think it's precise enough if you absolutely need a rounded off answer. So this is approximately equal to 8 minus 4.898. And it's actually 8989 in the calculator. So when I round that to the nearest thousandth place, it should be 4.899. 8 minus that value is equal to 3.101 divided by 10, and all that does is move the decimal place to the left, leaving 0.3101, and I said round to 3 decimal places, so that 1 on the end is irrelevant. So here we have the final answer when written as a decimal. And here we have the final answer, or one of the final answers, I should say, when left alone and not simplified. Both are good. It just depends on the circumstances of the problem and what specifically you're being asked for on the test. And as a reward to those of you who went ahead and watched this entire video, I'm going to give you the 3 bonus questions right here. Not the answers, but just the questions, so you can come in prepared for those if you like. Number 1, I ask you to tell me something about the roots of this quadratic. And I will give you a hint. If you graph it, it does not touch the x-axis. And the third bonus is this question right here. If you check your notes on the quadratic formula, you should be able to come up with the answer. For the bonus questions, each correct answer in a bonus question will nullify an incorrect answer from the main test, but I'm not giving out above a 100. So even if you think you did really well on the main test, it would still be a good idea to take a stab at the bonus questions. See you tomorrow.